Hi guys, welcome back to my math YouTube channel. Today I want to talk about the cosine law. Guys, so far we have covered the sine law, which helps us to actually solve for triangles which are different than right triangles, which are mostly called as the oblique triangles. Okay, so guys, there are going to be examples and there are going to be triangles which cannot be solved just by using the sine law. Then one has to kind of figure out, or one has to use a different type of law, and that law is called the cosine law. In this video I want to derive the formula or this cosine law in general, and then guys, once we discover the formula, there's going to be three ways or three forms of expressing a cosine law, and once we establish those three, then guys, we are going to go ahead and use those three or combination of them to actually solve for triangles. Okay, so in order to actually verify, first we have to start by drawing a triangle, and in this case I'm going to draw a triangle which is going to be different than a right angle triangle. So let us say I have a triangle which looks something like this. And guys, let us call this, so part of the derivation for the cosine law is kind of similar to what we did with the sine law. We started by drawing the triangle, and let us call this A, B, and this is C. So what I'm going to do here is, guys, I'm going to drop a perpendicular from this vertex C onto AB, and this, let us call this point as D. So it divides this triangle ABC into two triangles, and in fact two right triangles. And in these two right triangles, let us call this H, and then guys, you can call it whatever you like. I'm just calling it H. And then guys, this is my side A, lowercase a, this is my side B, lowercase b, and this is my side C, right, lowercase c. So guys, what I'm going to do here is I'm going to call this length AD as X, and then if I call this length AD as X, and this whole length from A to B is C, then obviously this length from B to D would be just simply C minus X. So this is my C minus X. Okay. Now in this triangle, let us focus on the triangle CDB. Guys, we are doing all this to kind of find or derive the cosine law. Once we have it, then we're going to use that law to solve triangles. So in this triangle CDB, let us apply the Pythagorean theorem. So using the Pythagorean theorem, we have the hypotenuse. So we got to write hypotenuse squared is the sum of the squares of the lengths of the other two sides. So it's going to be equal to C minus X whole square, and then of course the other side is the H, so it's going to be plus H square. So I'm just using the Pythagorean theorem on the triangle CDB. So guys, let us go ahead and simplify the right hand side. So on the left hand side I have A square. On the right hand side, when I simplify this, guys, it is going to be C square plus X square minus 2CX. Now I just wrote it out twice, and then I distributed, and finally this is what we get. And then I have a plus H square. Okay, so guys, let us leave it like this. And then from here, what I want to do is I want to now go back to the other right triangle, and let us focus on this right triangle ADC. Guys, in this right triangle, what about if we write the sine of A? The sine of A would be opposite over hypotenuse. So that would be equal to H. H is the opposite to angle A, and the hypotenuse is B. So guys, from here, if I solve for H, I have to cross multiply, and I will get H equals to B times sine of A. And we are doing it for a reason, and you will see as soon as I start substituting this H back into my this equation, right? So guys, this is one of the things that we need. The other one that we need is going to be something that we can figure out by finding or writing the cosine ratio for the cosine of A. So how about for the same triangle? So let me try to do it right here. Okay, so for triangle ADC, we have the sine, and similarly, if I have to write the cosine of A, guys, we know cosine is the adjacent over the hypotenuse. So adjacent is X and hypotenuse is B. So if I cross multiply this ratio, I get X equals to B cosine of A. So I did this whole thing just so that I could get H and X in terms of the sides and the angles. So guys, what I'm going to do now is I'm going to just take this up, and I'm going to write A square. I'm not going to do anything with the left hand side. And on the right hand side, C square, I'm going to leave it like this. X square, guys, X, I'm going to replace X with B cosine A. So it's B cosine A. We got to square that because it is X squared. And then guys, I have minus 2 times C, and then I have X again. X will be replaced by B cosine A. B cosine A. And then guys, I have one more thing, which is plus h squared. But what is my h? H is b sine a, so I'm going to replace that by b sine a. Guys, I still have to square it because it says h squared. Okay, so I got rid of the variables x and h, and everything now is in terms of a, b, and c. Okay, so now simplifying the right hand side again. So let me make some room here so that I can fit in, I'll try to fit in everything in one line. So I have a square on the left hand side. Guys, on the right hand side, I'm going to simplify. So I can say c square, I'll leave it alone. This I can simplify as b square and cosine square a. Then guys, I'm going to rearrange as well. And then what I'm going to do is I'm going to bring in the b sine a square before this term. So I'm going to simplify this and write it next to b square cosine square a. So it is b square sine square a. And then there's a minus the last term, which is going to be, I'm going to just rearrange this 2 times bc, and then there's a cosine of a. Okay, guys, this is little simplified, but we can simplify this further. Let us go ahead and simplify this further. Guys, left hand side is a square, the right hand side is c square. And guys, between these two terms, we can take out b square as a common factor. And let us see what is left inside the parentheses. Guys, I have a cosine square a from this term, and then I have a sine square a from the other term. So we are going to kind of group them together. And then I have minus 2 times bc, and then I have this cosine of a. Good. So guys, moving on, this is a square equals to c square plus. Guys, we know the basic Pythagorean trig identity, that the cosine square a plus sine square a is just simply 1. So you can replace this whole thing by 1. So b square times 1 is just going to be b square. And then there's minus 2bc. And then there's this cosine of a. Guys, I'm going to rearrange this a little bit more. So I'm going to have b square first and then c square. I just want to be consistent. A first, then b, then c, and then minus 2bc. And finally, I have the cosine of a. And guys, this is the cosine law. This is one of the forms for the cosine law, where we have side a square equals to the sum of the b squares plus sum of the plus c square minus 2bc times cosine of a. And keep in mind, guys, when we are using the cosine law in this form, guys, b and c, if we use two sides as b and c, then a is the included angle, and we can see that from the triangle from the figure here as well. B and c has the included angle a. Okay, so that is how we like to kind of remember this, that whenever we use two sides, we have to here multiply by the cosine of the included angle. Now this is only one of the ways of expressing the cosine law. Guys, there's 2 more ways. And to get the other 2 ways, we're not going to derive it here. They are going to be derived in a similar way. Guys, for that, what we can do is, one of the things that we can do is, instead of calling this x, we can call this length as x, then automatically this would be c minus x, and we kind of follow the same procedure. And if we do that, then guys, we're going to get a little bit different form. Similarly, if we drop the perpendicular from a different vertex onto the other side, then we'll get a different equation. So guys, in total, we'll get 3 different equations. We are going to write all 3 of them here, but all 3 can be derived in the same way. Okay, so the other 2, I'm going to make room for the other 2. I'm just going to write them, and then we know now how to derive these things. So this is one of them, and the other 2 forms for the cosine law are going to look like this. This is the first one. Let us call this the first one. The second one would be b square is c square plus a square minus 2ca times the cosine of the included angle. So cosine of the included angle between c and a. This is c, this is a. The included angle would be b, so it would be cosine of b. That would be the other one. Okay, and then the third one would be c square equals to a square plus b square minus 2ab times the cosine of the included angle, which in this case would be cosine of c. So guys, these are the 3 ways of expressing the cosine law. So one may have to start by using one of them, and then one has to use the other one to find the other missing pieces. Guys, keep in mind that this kind of looks similar to a Pythagorean theorem, and it is kind of an extension of a Pythagorean theorem. If my angle, any of the angles here is 90 degrees, then basically this term vanishes and it becomes a Pythagorean theorem. But since we will be dealing with angles which are different than 90 degrees, so we have to use this law as it looks like this with the cosine terms as well in all the 3 cases. Okay, so guys, it is not too complicated to derive the cosine law, and here we have the 3 ways of expressing a cosine law. Now in my next video, guys, we have established here all the 3 forms. We are going to use these forms to find the missing sides or angles. Okay, guys, till then, take care. I will see you in the next video.